Good morning. I will present you now the second configuration we have studied during the Endure project. So the second configuration is composed of a mussel farm located on the shoreline, and we would like to analyze the impact of this mussel farm on the dune formation. In the previous presentation, we were inside the Oti estuary. Now we will move a little bit more in the north between the city of Berck and Merlimont. The farm is about 1 kilometer in length and about 100 meter in width. It is located in the lower interval area, and the coastline are perpendicular to the coastline. The different lines are spaced about 25 meter in the along-shore direction. As you can see on the figure on the left, each line is in fact composed of two rows of posts, and each row is a space of 3.5 meter, still in the along-shore direction. On the second configuration, we have also conducted some field monitoring. So we have different datasets. We have beach profile that are conducted twice a year by the DDTM, which is a state office in France. And we have conducted also some survey with flying drones to measure the topography. So we have more detailed dataset with the drones, but they are more it's more local survey near the farm. Then we have also conducted some hydrodynamic measurement, tide and wave. Now I will present you some results from the in-situ survey. So on the top, we plot two topography survey, one in July and one in September. And then from this profile, we can from this dataset, we can extract some profile, along-shore profile or cross-shore profile. So the figure you can see on the left below, it's cross-shore profile. So the 0 corresponds to the location of the mussel farm, and then we move to the dune. So what we can see on the along-shore profile or the first meter of the cross-shore profile is that we have some erosion between October to March, and then we have sedimentation from March to July and September. Well, if we look a little bit further, between 100 meter and 300 meter, we have the inverse situation. We have sedimentation between the winter and then erosion during the summer. For the hydrodynamic monitoring, we have performed two surveys in 2020. We have performed a 1-day survey in March, and we have performed 15-day survey in June. So the second survey, we have the whole NIP spring cycle. So we locate the sensor at different locations in the mussel farm. So what you can see on the below is the result from the first survey during two tidal cycles. Here you can see the measurement we have extracted from the second survey for the 15 days survey. So the one in the middle corresponds to the western sensor, and when we have 1 meter above the sensor during the nip tide. For the two other in the eastern part, we have dry configuration for all low tide. From this water level measurement, we can extract information related to the wave. For instance, the mean height of the wave. But then if we compare the three sensors, we see that we have very small difference, about 4 and 5 millimeter. So we are reaching the accuracy of the sensor, and then what we can see is that it's difficult to determine if we have some damping effect induced by the post in the cross-shore direction. So it's probably due to the fact that the farm is quite small, like only 100 meter in width. For this configuration, we have also built a numerical model. It's a 2D numerical model when we consider only the tide influence. The diameter of the post are quite small, by 12 centimeter, so it's not possible to physically include them inside a numerical model. So as an alternative, we propose to reckon this post as a rigid vegetation and a parametrization of the friction coefficient. So we determine in the literature different relationship for rigid vegetation, and we select one, which is when we can link the friction coefficient to parameter linked to the post, the density, the height of the post, and the diameter. And then we can see what will be the effect of this post on the circulation. So here are the results from the numerical model. You have two figures. So we compute a nip spring cycle of 15 days, and then we extract the residual current. So the residual current are oriented from south to north, and they are dominated by the flood. So on the left is the configuration without the post, and on the right is the configuration with the post. The location of the mussel farm is represented by the dot line. So what we can see is that when we include the post inside the numerical model, we have a reduction of the residual current in the area where is located the farm, inside the dot line. So it means that the presence of the post will induce a reduction of the sediment transport in the along shore direction. It may result in sedimentation. But as in the numerical model, we only reckon the influence of the tide. It corresponds to a summer condition when the wave activity is low. So we have seen in the beach profile that we have sedimentation during the summer near the post, and then during the winter, the sediment can be remobilized by the wave activity in the winter. So as conclusion, we can say that due to the dimension of the farm, which is quite low or small, especially the width direction, and because the density of the post is quite low as well, we do not see a clear effect in the cross-shore direction. With the numerical model, we see some effect in the longshore direction, and the reduction of the residual current in the longshore direction may result in sedimentation during the summer, but it looks like this sedimentation can be eroded during the winter. So if we want to use this mussel post as dune protection, we will need to increase the size of the farm with more posts, and also to increase the density. Or the alternative could be to use the sand net to increase the wave damping. So thank you for your attention. If you have some question.